So let us start area vector. Who is there behind? Someone is creating noise.
And the windows. 1 minute.
Yeah. So study today what is an area vector. Normally area is a scalar. Area is normally a scalar quantity, isn't it?
Yeah.
So it's meter square per unit. But it can also be made a vector. Area can be as a vector.
Are you writing something on the screen?
You know,
No, I cannot see it.
can share it. Can you see now?
Oh yeah.
Area can be used as a vector. How?
Yeah.
Example we do is we have an area, suppose this some area. It's lying this plane, suppose this is xy, and this one vertical inside the screen is the z plane, right?
Yeah.
So this area is in the xy plane, okay, this plane. Now if we draw a normal to this vector or normal to this area, normal to the area line is perpendicular to it, so like this, it is coming out of this, okay?
Yeah.
This vector, it is coming out of this square at an angle 90 degree.
Okay.
This is outside the screen, and this normal vector, the area, okay, this is a normal vector to area. It can be used to define the direction of this area. So this is how we define vector to a area.
Okay.
What we do is we just draw a normal to that area, and that normal is the area vector. Okay, this is called area vector. Suppose
Okay.
suppose the plane is like this. Okay,
Yeah.
so it is vertical, right?
Yeah.
Vertical, so it is in xz direction. All right.
Yeah.
Now we will draw normal to this vector, which will be like this in y direction, isn't it? And the area is in x
Yeah.
y plane. The normal to that is in the z direction.
Z direction. So
When
this
this
one will be
area
Y.
is in this plane, okay, the area is in this plane, right?
Yeah.
And naturally normal would be either this
And
way or
Y.
this way. Both of them would be along the y axis, right?
Yeah.
So this one is the positive y. You can also take on the negative y. We'll talk about it later, but anyway, this is a normal to this. So
Okay.
this would be in the, now this is the area vector of this, the area normal line. With respect to the
Yeah.
plane, this is making an angle 90 degree. area vector is used in physics. All right. So
Yeah.
suppose we have a small area or even big area. Suppose this is area S, right? And this normal is an unit vector. Okay. And what we say is d this S vector, the area
Yeah.
vector would be equal to S multiplied by this unit vector, isn't it?
Yeah.
This would give the area vector normal to the, remember this area vector is normal to the area, right?
Yeah.
So you should remember it, the area vector to a plane, this is a plane, right? Area vector to a plane is normal to it all, an angle of 90
Mm.
degree. Okay.
Yeah.
Similarly, we can define a small area ds. Area is ds in the xy plane, and normal to it be in z. This ds
Yeah.
vector, ds into n f.
Yeah.
ds is a small area and s is a big area. This is what a area vector is. Now, if we are given a cube like this, six surfaces, six six planes can be made out of. Now we want to find the area vector front. Okay,
Yeah.
in the xy plane, this area.
Yeah. Exactly.
So the normal to it be in
Will
this,
be Z cap.
like this, right?
Yeah.
Vector.
Oh wait, it won't be Z cap.
Yeah, this is z,
I mean
no?
Z.
So x, y is z.
Yeah.
Cannot draw it, no? So that's why
Yeah.
we have to zoom it. So this is z,
Okay.
right? Suppose say area A is named as A, right? And what would A vector be? A into normal vector.
And yeah.
Now, can we define this unit vector in the negative z direction, like inside the cube? Because that is also a z.
Yeah.
Tell we have inside, this would be the negative z, but it would
Yeah.
still be normal to, that would be negative, and you know, this is
So
not,
that will be correct.
no,
That's wrong.
yeah.
Oh, I don't know
According to
why.
convention, this is wrong. So according to convention, we do is generally uh, this normal vectors or area vector is taken outside, outward. Okay.
Yeah.
Whenever there is a closed figure, then the vector area vector is taken, which one?
Outward.
The one which is in outward.
Okay.
So this is what an area vector is. That is a start. Flux. Okay.
Yeah.
Suppose there is a space, and space there is electric field. This is electric field. So we have taken a small area. So like this some area or this angle, this area. Now we want to find the number of electric field lines passing through. Area
Okay.
is A, electric field is E per electric field line passing through A.
Passing through air.
Find this. That is
Okay.
all. That is called electric flux.
Oh, okay.
So more the number of more will be the flux, and if there are less number of lines passing through a given area, then the electric flux would be less, right?
Yeah.
It is denoted by phi, phi symbol.
Yeah.
Phi is E dot A.
E dot A.
This is the dot
Okay.
product. All right. This is
Yeah.
electric field. This is area, and if you do this, perform this operation E dot A, you will get the flux. Okay?
Okay.
So if you see in the diagram, you can see same thing that I've drawn, right?
Yeah.
Is the number of electric field lines that pass through a given surface. Now this surface, this area, right? This
Yeah.
this area was the x z plane, okay?
Yeah.
Hence the normal unit vector to it was in the direction this y direction, and n vector,
Yeah.
which is in the direction of v, right?
Yeah.
In this way you can easily find, but what if the electric field is like the area is this is the area, and the electric field is like
Yeah. Yeah. So
this is the electric field. Now in this case
I want to be the same.
the area is in the xz plane,
Oh, okay. Okay.
right?
Yeah.
And the normal unit vector to it is this one. So now in this case normal vector and electric field are not the same
Yeah.
direction, right? They are having
Yeah.
so the angle between them is like this theta angle, isn't it?
Yeah.
This is the angle between electric field and normal unit
No, no.
vector,
Yeah.
normal area vector, not the angle between something else. The
Okay.
angle between electric field and this. So now in this case what we do is, see, in this case, like, not all the electric field pass through the total area. You know
Okay.
why? Because see, this, if this is theta, right?
Yeah.
If we zoom it, like if this is E, this is theta, all right?
Yeah.
What would happen? This if we like This did not change. Why so?
I thought it.
Sometimes it creates problem.
Is it because of the new update?
So I was telling that this is the angle theta between the electric field and the normal area vector. So if you resolve E into two components, this would be E sine theta, and this one would be E cos theta,
Are
isn't
you
it?
writing something?
Electric flux definition says that the electric flux is the number of electric field lines passing through the area, through the normal vector area. A electric
Yeah.
field lines passing through A.
Awesome.
So only this component of electric field E cos theta be taken into consideration. Only that component is taken into consideration. So this phi would be this electric field component into what? This is A, right?
Into N.
Now that the formula is E dot A, which is
Yeah, E
okay.
dot A dot product, yeah.
So E, and it is EA cos theta, right?
Yeah.
This is the direct formula that I have wrote for you, but we are proving it, right? Okay.
Okay.
We are proving how this is E dot A only.
Okay.
When we calculate phi, what we do, we take this component of electric field which is in the direction n vector. E dot A
Yeah.
into area, which is A, or whatever you say, S. Did I wrote S earlier? No, I wrote A
You
only,
were
so
A.
A. And what is E A cos theta?
I don't
It
know.
is E dot A itself,
Oh, okay, dot product. Okay.
isn't it?
Yeah.
E dot A is E A cos theta. That's how this formula came. Because we need to find the component of electric field which is in the direction of this normal area vector, and that would be E cos theta at all time, if theta is the angle between electric field and this. So
Okay.
pretty simple. You just, whenever you need to find phi, the flux, what you do is you just find E dot A.
E dot A.
So
Okay.
I should mark arrow represent that it is a vector.
Vector.
So dot product is between two vectors.
Yeah.
These are two vectors, E and A. And what is A vector? This is just A into an unit vector, isn't it?
Oh,
Total number of electric field lines
yeah. Passing
passing
through
normally through that area.
A. Okay.
Okay, it is important to mention normally to the area. Okay.
No,
For example, let us consider a case. Suppose this is the area, right? This is the area. Okay. Now, this is suppose X, Y. Now electric field is in this direction.
Okay.
It is Y direction. Now what would be the flux in this case? Would there be any flux? See, by visual inspection we can say,
No, I don't think so.
yeah, no flux, because this area is not perpendicular to
I
this.
mean, between.
So the area unit normal vector would be like this. Okay,
Yeah.
this is small one would be n cap. So what we see here, that the angle theta between electric field and normal is what, 90 degree,
90 degrees.
and phi is E dot A, which is E into A into cos 90, isn't it?
Yeah.
because theta is the angle between what? Normal vector and this electric field, which is
And
obviously 90.
electric field.
And cos 90 we know is 0. Phi would be 0, no?
Zero.
It was obvious from the inspection that this area is not cutting the electric field lines.
Yeah.
Whenever the electric field lines cut the area, in that case we are only getting the flux. Okay,
Yeah.
and the maximum flux is there when this area would have been like 90 degrees. They're like this case. So here it is
Sure.
the angle between this area, sorry, normal unit vector and electric field is 0. That means this full area has been exposed to the electric. Here no
Yeah.
area is exposed to the electric. Electric field lines here won't pass through it. Okay,
Yeah.
it will just glide over it. And so passing is different thing. Okay,
Yeah.
it passing means to cross something. Like there is some barrier, you should enter it and exit it. Here electric field lines are not crossing this cross section. This cross section.
Yeah.
That's why flux is, and hence this definition that E dot A is the flux. Now see the next thing. Suppose we have small surface. Suppose this is a bigger surface, and in this surface we have small surfaces, each one of ds area, right?
Yeah.
Now this thing that I just told you, that flux is E dot A, is valid only and only when this electric field is a constant. You can see everywhere that I took a constant or
Yeah.
uniform electric field.
Yeah.
All right, here also took uniform electric field. But if there is a non-uniform electric field, then this will not be true. Okay,
Okay.
so in this case let us consider this is a surface. Okay, this is a
Yeah.
closed surface S, and in this surface uh like the electric field at every point on this is different. Okay, we have assumed
Okay.
that E is not uniform, E is non-uniform here. E is non-uniform, the magnitude of electric field at any point is different. Okay, so
Yeah.
what we do is, in this case we take n small areas, so ds1, ds2, ds3, dash 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 dash, dsn, let's say. Okay,
Yeah.
right, and the corresponding electric field at each one of these areas, let's say it is E1, E2, because it's different, na, that's how we are assuming it.
Yeah.
The electric field at every point is different. There would be many electric fields En, correct? And why we
Yeah.
took this ds is a very small, like minute area.
Small. Yeah.
Electric field at every point can be assumed only by this thing only, when there is the area is very small. Electric field at every point. Well, now in this case what a normal person would do is, let's say we just add the flux due to each one of these small areas. So what he would do is E1 dot ds1, isn't it, plus
Yeah.
E2 dot ds2,
Two.
plus, makes sense, right? Close
Yeah.
ds3 plus dash dash dash
Two and
E n dsn. This is practically not possible to add infinite, actually, when when this is a large area. Okay, We have assumed it as the n, but in actual scenario this is not n. When we have assumed small surfaces, they would be infinite. Okay,
Yeah.
these small surfaces would be infinite in number. So first of all, let's write what would be the final result of this, and then we proceed. Final result of
Oh,
this
okay.
would be the summation e uh, I dot del si, where I goes from 1 to n. I told you last summation what summation means. This is the
Yeah.
same thing that we wrote above, just the compact form of it.
Yeah.
So each one of these I will give you one term, right? And you put I is
Yeah.
equal to 1, you get first term, I is equal to 2, the second term, I is equal to the third term. And this summation means you have to add all of those terms.
Yeah.
Now
So,
when,
okay.
no, because we have to make it uh, practically
Yeah.
implementable, because n is not finite. So in
Yeah.
practical cases, when n is infinity, okay, and delta s,
Yeah.
we know that it tends to 0 when it is very small. Then what happens is that this summation here reduces to an integral, because I told you that integration means add up, isn't it? Sum.
Yeah.
So when we have continuous things, this we will also study in math in detail, but for topic we'll just tell you what it is. When we add continuous things, right, we use this integral, and when we add discrete things,
Use delta.
hmm,
Summation. Summation.
yeah, we use summation when the things are discrete, like they can be distinguished from each other. But you
Okay.
know what, when this is 0, delta s tending to 0, and n is infinite, this becomes a continuous thing, the whole picture here. Okay,
Okay.
you cannot distinguish one area from the other, they are so close. And n is also infinity and is not a constant value or finite value. So this, what happens is, this summation is just reduced to an integral. Okay,
Okay.
and rest is same thing. So this is the formula used to find the flux, and E is non-uniform.
Okay.
Okay,
So in the textbook, why is there a circle
here is the circle.
on the integral?
Oh, so actually circle means the closed integral.
Okay, what does that mean?
It is just a notation to mean that we would have to take each one of these parts in this closed surface. We cannot leave anything.
Oh, okay. And
That
why is
is,
there an S underneath it?
there is this S. Where is this
No, like
S?
under the integral, there's an S.
So that means, this means the closed integral over the surface S.
Oh, okay.
The closed integral over surface S, right?
Yes.
This is how we will calculate. Now this is the actual formula, this should be used. Actually, we say the general formula, because this formula can also be used when E is uniform. Okay,
Yeah.
this formula is valid for everywhere, but this E dot ds is used only when we have a uniform electric, this one. Okay,
Yeah.
next. Okay, so unit of electric flux, what should be the unit? See, E, electric field is what?
Motion per coulomb.
Turn per coulomb, right? And what is
Yeah.
area? Meter square. Simply, you can say that the form, the unit Newton meter square per coulomb. Okay.
Okay.
And there is another unit that is used quite often for flux. Alternate to this is voltmeters. We will study that later how we get this unit. But this is also
Okay.
one of the SI units of electric flux.
Okay.
Voltmeters.
Sure. Yeah.
So this is the electric. Is there some question? There is a question. Let us do this. Small one. The question: the electric field is given by 6 I cap plus 3 j cap plus 4 k cap. Calculate the electric flux through a surface of area 20 units in YZ plane. You know what this means? What does this mean?
Yeah.
This
Uh,
means the electric field is present in three directions. IJK.
yeah. RJK got it. I
We
mean,
cannot draw it on the paper. Like it could be like this sphere.
like one would be in the direction of I, and the other one JQ. Right?
Yeah.
Okay.
In every direction, X, Y, and Z. Because there are three components, I, J, and K.
Yeah.
But we need to find the flux through the surface of area 20 units in YZ planes. So I
Why
do
is that P?
YZ.
It would be 3J plus 4K. I don't know.
We need to find flux now. So YZ plane, first of all, this is the YZ plane. And
Yes.
can we draw a area in this? This is the area in this.
Yes.
Let's say this area A is 20 units. And the normal unit vector to this would be in this direction. So if
Yeah.
this is YZ plane, then the normal unit vector will be in X direction.
Yeah.
This is area and this is normal and cap. We need to find the flux. So what is the formula? I is, see, this is not a non-uniform electric field. This is still uniform. Okay,
Okay.
it's that it is present in three directions, but it is not uniform. It would have been non-uniform, when suppose it was increasing or decreasing with respect to any one of these. Suppose this was 6x I cap, okay,
Okay.
or 3y j cap, like something like this. That means that for every x um, that we reach, example x is 0.1, then the different electric field x is 0.5 meters, different component of I vector, right? X
Yeah.
is two different I vector component. But here I vector
Yeah.
component is fixed, j vector component is fixed, k vector component is fixed.
So it's uniform.
Yeah, no matter where you move in the 3D plane, okay,
Yeah.
it would still be the same. But this is varying with respect to the x, the distance, the y distance, z distance. That would be non-uniform. This electric field is uniform. So the way we can use this formula E dot A. What is E dot A? E A theta.
Cos theta.
Okay.
Yeah.
So okay, so we don't need this. I think we can directly use E dot A. You know how do we find dot product when we are given I j k? Hmm.
No. I
First of
forgot. I
all,
was reminded to
okay,
remind
okay, I'll
myself.
tell you. First of all, we can find what is A, right? A vector, isn't it?
Yeah,
What is A vector? A, I told you A into N.
and yeah.
Okay? And N unit vector, we can say that this is I unit vector in this case. Because N is any unit vector, right? But
Yeah.
here we know N is in the X direction, isn't it?
Yeah. Yeah.
So what we can write, A is 20 from the question, area is
20
20.
I got.
Yeah, this is A,
Okay.
right?
Yeah.
Now let us find E dot A. I is E dot A,
So it will be 6
6I
I cap.
3J or K dot product with A. A is just 20 I cap, so you
20
can
I.
write 0J and 0K, right?
Yeah. Oh, and then do you like add I cap to I cap?
Multiply it, so 6 to 2 120.
120.
I cap will be gone in dot product, right?
Yeah. Yeah.
And here it is all 0, so just this component will be there. I is 120.
Oh,
Yeah,
okay. So 120 minutes.
not
Newton
minutes,
square.
this. Let's just find dot product, nothing else, right?
Okay.
Okay, let's do one more
Okay.
based on it visible.
Yeah. It's blurred, but okay. It's like I have the book also.
Doesn't matter. Circular sheet of plane, sheet of radius 10 centimeters, so radius is 10, that means 0.1 meter. There is a circular sheet, so this circular sheet, say, and it is placed in a uniform electric field 5 into 10 to the power 5 newton per coulomb, making an angle of 60 degree with the field. Okay, so what he says is, uh, diagram given now. Actually, I cannot draw. This is in, so this is the area, right?
Yeah.
Now he is saying that this area is making 60 degree with the field.
Okay. Okay. Okay.
So
So cos theta, I mean theta is 60.
no, theta, not 60. That what?
Um.
Actually, theta is the angle between
Wait,
the.
wait, 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 wait. So it's saying that it makes an angle. The normal is making an angle with
No, that's
theta.
what normal is not making. The area is making.
Electric field. Okay.
Okay, the area is making an angle of 60.
Oh,
Suppose this is the electric field. Don't know if I can draw.
so it's making an angle 60 degree with the electric.
Yeah, the area is making the angle 60 with the electric
Yeah, okay,
field.
okay, okay, I got it.
But the normal would then make angle of 30 degree,
A
you know.
90. Oh, what?
See na, uh, how can I tell you this? Hmm. Okay, so see this diagram, right?
Yeah,
What is the angle between the electric field? This is the electric field, right?
yeah, yeah,
And the normal unit vector, it is theta.
yeah. Okay, yeah, so you
But
said
this
like
one angle, this angle, the angle between the area and the electric field. Th-
Uh,
That's
okay.
90 minus theta.
Yeah, yeah, okay.
The remaining angle, okay?
Yeah.
So that it is given to us. Okay, that angle is given. The angle between the area and the electric field is given. So the angle between uh, normal unit vector and electric field would be the 90 minus theta.
Okay.
You got it?
Yeah. So theta will be 30.
Yeah.
Okay.
If this is the normal vector now, so if this is the normal vector, right?
Yeah.
Area vector, this is normal vector. So this angle is now 30 and the other one is this which was given to us 90 minus theta. Isn't
Oh,
it?
well,
This was given to us which is 60 degree, right? But
well,
we need to find the angle between this area and electric. This is theta. Then it is easy. First of all we should find the area. So what is area? Pi r square. Okay.
yeah.
Should we take 22 as 7 or is it side in the
It's not specified.
3.14 years taken? So let us take r is zero point 0.1, so 0.1, 0.1, 0.01, right?
Yeah. So 0.41.
It is 0.031, right? So phi
Yeah.
would be e dot a, e into a into, what is e? 5 into 10 to the power 5 into 0.0314. When you solve
Cos
this,
here is, I mean, cos 3 is
cos
under
30
3
is,
by 2.
yeah, solve this at 1.3 into the Newton.
Okay. Yeah.
How we do this question? So I think it is enough for 6. The
Right.
next class we will discuss the Gauss law and its application.
Okay.